It's also important to talk about loading the boat when we're making turns. So the safest possible application, particularly in John boats, to prevent rotational capsizing, is that we always take our rescue personnel that are in the boat and we put them on the downriver side of the boat when we're making turns. The way that translates is when we're traveling upriver, if I call hard right, all my personnel in the boat are going to go to the right side of the boat. If I call hard left, all my personnel are going to go to the left side of the boat. It's the exact opposite when we're traveling downriver. So if traveling downriver and I call hard right, it's going to be all of our personnel to the left side of the boat. If I call hard left, it's going to be all of our personnel to the right side of the boat. Now, you can't use those as absolute applications. You need to understand your boat, how much it's going to dip, and what the possibilities are of it taking on water when you're making those turns. In downriver applications, one example of where we're going to lean into the turn or on the upriver side is when we're trying to do a downriver eddy turn or negotiate an obstacle where it's imperative that we make a very tight turn. So understand your boat, understand its limitations, and apply your boat loading with terms appropriately based on your boat's performance capabilities. The key ingredient is to making sure that you don't take in water on the upriver side of the boat when making turns and result in a rotational capsize of the craft. All right, when we seek eddies in our craft, we're gonna have upriver approaches and we're gonna have downriver approaches. There's basically a current differential or a keeper behind any significant obstruction in the river base. So what you want to do is you want to ferry your boat over when you're traveling in an upriver application, drop into that eddy, and as soon as you're in that current differential, if you're still under a lot of throttle because you're resisting a lot of current, you got to make sure that you get off the throttle and dial it back down, and sometimes you even have to goose it in reverse just a touch to prevent from slamming into that obstruction that's creating this eddy. Once you're in that zone, it's a safe point that can completely keep the boat right where it needs to be. You just got to watch your rudder control. These are great havens to seek, to either make operational changes to your craft or to deploy throw lines and reach lines to our victims to try and bring them into these areas to go ahead and procure them, particularly when we're in current that's significant enough that we're not navigating upriver real well or real effectively. So that's our upriver application. On a downriver application, when we come into eddies, we want to be about one boat length away from the object or closer. And when the nose of our boat is in close proximity to that objective, we're going to do a tight peel turn into that eddy, which basically brings the rear end of the boat around and drops the craft right into that eddy. You want to make those turns tight, but you really got to watch swamping your boats or capsizing when you lean into those turns coming into those eddies. As soon as you drop into the eddy, also ensure that all your personnel neutrally load the boat as soon as you drop into it so that the boat doesn't pitch the other direction. And as soon as you drop in, immediately off the throttle and let that objective keep you right where you're at. When we come out of eddies, we have two choices. We can either do a downriver eddy turn, so as we would push off of the objective, set a ferry angle coming towards the width of the river, and then do a tight turn, headed downriver, and then get turned back around to head towards our objective. Or we'd set our ferry angle coming out, and as we come out of that crest, we're gonna have to counteract what that river's trying to do to the ferry angle we've set, motor it around, and then start trucking upriver.